So we're going to talk today about how you can have the perfect storm of innovation in the world's largest bureaucracy, the Department of Defense. In October of 2016, I traveled with the Defense Innovation Board to the Combined Air Operations Center, known as the CAOC. All DoD things have good acronyms. And that picture is what you see. Big screens, lots of airplanes. This is how we are prosecuting the battles in Afghanistan, Iraq, and Syria. Unfortunately, it looked no different in 2016 than it did 10 years prior when I was there in uniform. The greatest innovation was Excel macros and PowerPoint. In specific, one of the things that CAOC does, it plans the entire air battle, is it plans where air refueling tankers will be at what time, at what place, so a fighter can get gas. And if they're not there at the right time, now it's a bad day for all involved. This is how they were scheduling it. A whiteboard with markers, a team of 4 people sitting on Excel macros calculating fuels. It took 60 man-hours to build the plan every day, and they've been doing it for 17 years. Mistakes were made, no lessons were learned, and so we said, we think there could be a better way. We want to change how the department does software. There's modern techniques. I think we can make this better. So that evening in the hotel room, I called Enrique.
Yeah. Okay, so Raj gets me a call, and at the time I was kind of inspired to do some software development. I'd been living out in the Valley for a couple years, and we were going to experiment with some really kind of like experimental software. He calls me and says, forget all that experimental stuff, you're actually going to build software that people are going to use in a real war. As I learned later, that's actually having a real user is probably the most important thing to build good software. So I took my team of 6 developers who didn't know what they were doing. I said, guess what, we're building tankers, planning tools, we're going to try to figure this out. Most important thing I learned, design matters. It is hard to design something better than a whiteboard. They are incredibly easy to use as a user. And trying to do software that makes it as easy as the whiteboard is really hard. But we did it. And the reason we made it easier was not on the user interface, although user interface actually works okay. This is an older version. What matters is we did the back-end math. As Raj said, they had Excel spreadsheets. Literally a 23 megabyte Excel spreadsheet that was nothing but macros. The guy who built it is an amazing genius. He really was. And so we brought him and said, okay, what's all this math you used? And we recoded all the math into Java, try to find people that can do JavaScript, which by the way in the US government is very hard because nobody cares about the front end. So finding someone that can do HTML and JavaScript was a near impossible task for us. Plenty of guys that do Java, C, Jovial. Anyone used that before? So this was our first tool. Since then, we've now deployed 5 applications into combat operations. Our 6th one will go live this week, hopefully by tomorrow. So we have a dynamic targeting tool of how do you target something. Yeah, so how do you target something that wasn't pre-planned? That was kind of hard to do. Again, we were hitting targets using Excel spreadsheets and Word documents. How about some more deliberate planning? Take some time to actually look at the intelligence on something. A lot of the stuff was being passed around, again, Excel, the primary weapon of choice for the US military. But we're getting better, and we're now setting up a full team to do some of the work.
So the real lesson here is not how to build a tanker tool, but how do you build modern software in the department? And how do you scale this effort? So what we want to talk here now for our last half is, what are some of the lessons learned that we had to try to change this program, which was a $750 million program that was entering its 11th year without delivering a line of code to an actual user. How did we do that with 12 weeks, 10 people, and less than $1.5 million? So we built a formula. What does it take? Believable warfighters, some real technology, just a bit of money, senior support, and a healthy irreverence. Believable warfighters, got to work on problems that matter. If we solve the defense travel system, hopefully no one here has ever had to use it, that would probably save the department more money. But we worked on things that matter. Here you see a Predator feed. I went and visited these folks. They had jerky video because they were running Windows XP, 32-bit system. They couldn't use memory, right? But it mattered for this person because he was using that antiquated system for live combat ops in Syria.
Right. So once you have the believable warfighter, you have to have real tech. For a lot of senior leadership in the federal government and the DoD, I'm sure at state and local levels as well, a lot of this tech is magic. So we need to bring in some real technologies. And technology is sometimes very simple stuff. So we have a lot of people in the military that do software development. But they don't use modern tools. So the standard practice of using Concourse and Jenkins, using modern programming languages, using commodity hardware, using cloud compute. These are really anomalies in the federal government at the moment. And I know DDS, USDS, Defense Innovation Board have really driven this message home, and that has actually really helped us, that they've been advocating for the same tech that we're trying to do at the local level. But in addition to tech, there's methodologies. Everybody does agile. Everybody loves agile. I've seen the word thrown around by almost everybody in the federal government now. Real simply, you do little sprints, you stand up instead of sitting down at your meetings. What else do you do? You use sticky notes to track your tasks. And the moment you do that, you are an agile god. That's the problem, though. In the federal government, we take a beautifully designed agile methodology and we do this with it. We still insist on requirements. We still write technical requirements by people who are usually not technical, or by systems engineers. I apologize to systems engineers, but every once in a while we should actually allow software engineers to write some requirements. Then we go through a year and a half long contracting process. Somebody then designs it to the nth degree exact specifications. Takes a couple years to do that. Then to do agile development. 1 week sprints, 2 week sprints, and about 3 years into it, they might show code to a user. Then you go to testing, and everybody knows what happens when you've never shown the code to anybody. It's going to fail in testing. Then goes through the security process, which, are there any CISOs in the room? Any? None? I don't see any. Yeah, these are the worst. Security should not take a year, and especially when a formalized, documented process is a year. If you're doing security right, if you're doing a real agile process where you're scanning your code as you're committing to Git, then you shouldn't need a year-long security process at the end. But of course, you deploy with fanfare. Everybody loves the press releases. We do it all the time. And then it goes to some guy in the field who was probably not alive when that original strategic requirement was written. And then they get yelled at every day of why doesn't it work? Well, they don't know. They were never involved in any of the process to begin with. So this is agile in the military, and this is what we have now broken in a couple small use cases. Oh, money, sorry, my slide as well. So what does it cost? To get us started, the design was only about 100K, just to say, hey, we could do this. Ooh, okay, build didn't work. Real quick, 100K. To actually build a product, including the hardware and software, it's only about 2 million. To start building more products, only about 12 million. Here's the problem with the government. If you only ask for a couple million, you're only going to get that forever. So how do you, it's like a prisoner's dilemma. Who's the first organization to say, we don't need $50 million this year, we only need 2 million this year, but we want to keep scaling? So this is a part that we're still trying to break, the acquisitions process, to say it's okay to start small and then grow. Everybody wants to start big up front, and it's kind of tough.
Yeah, so while Enrique was building software and doing fun things, I was fighting bureaucrats. The most important thing that we found, though, is we had senior support. It takes someone high up to be personally involved, to say, I'm going to take the risk, I'm going to tell that security person to move faster. So to go back to the tanker planning example, it cost Enrique about $1.5 million to put the thing together. They found out because they could reflow the plan on an almost immediate basis rather than have to wait for the next day. What would happen previously, every time there was some conflict, some skirmish, and they needed new support, they'd scramble a tanker, i.e. they have a tanker waiting in a different base, it would fly out there. Each scramble costs $250,000 in fuel. They were saving 3 a day. The tool paid for itself in a week. Yeah. Doesn't take a lot of money. Needs senior support. The guy in the field, the whiteboard now, they've actually taken it to the Air Force Museum, so the next time you visit, you can go see it. And you need a healthy irreverence. People talk about clearances. We had coders from San Francisco that had never been in the government. We got them 24-hour clearances and got Macs authorized to use in the war center there at the KAOC. Finally, these are the things that we think and recommend folks that want to be innovators. Obviously, get the right team. Just do, plan less, focus on the user, fight mediocrity. But the thing I'll focus here in my last few seconds is this tolerate less real risk. People take the old methods because they think they're less risky. I would submit they're not less risky. All they do is transfer risk. It transfers risk from folks in cubicles who face the risk of paper cuts and bad light and carpal tunnel, to folks that matters, i.e. folks in the field, the users, the warfighters. They're going to fight with whatever they're given, and if it's substandard product, substandard code, they're going to do it anyways. So all it is transferring risk to the worst place, the guy's actually facing it. Thank you for your time. I'm glad to see everyone here.
Thanks. Right back on top.